Good afternoon, all. I am Dr. Partha Sarathi, Associate Professor, Electrical Engineering Department, Holdia Institute of Technology. This is my second lecture regarding Introduction to Microprocessor. In my previous lecture, I discussed regarding the application of microprocessors, what are its utility, and all. Some part of architecture I have also discussed at that time. Microprocessor, it is the heart of a computer. The computer which we use nowadays, microprocessor is its main part. Today we will discuss some specific uh, nomenclature or some specific terminology regarding microprocessor. So first is word length of a microprocessor. Now what is word length? Word length of a microprocessor means in our computer, if I go to my computer, right click on it, then go to properties, we can see some information regarding the computer, that means the desktop or laptop which we use. So if you study that part, you can see something written is there regarding bit, maybe 32 bit, maybe 64 bit, like this. Now, what is this? What that bit signifies? So, in digital electronics, we get the concept of bit and byte. Bit means a binary information, maybe a 1 or a 0. So, a 1 or 0 is called a bit of data, a bit of information. So, the computer which have larger bits, it is more advanced, more powerful. The computer which have less bits, it takes lots of time. It do not support many updated files. So like this, so it depends upon the architecture of the computer. Now, what is word length of a computer? What computer, or what is word length of a microprocessor? That word length is totally related to that bits. 8085 microprocessor, it is a very beginning stage of microprocessor. It is an 8-bit microprocessor. That means it can process 8 bits of data or 8 bits of information at a particular time. So, if that microprocessor, if I want to process 16 bit of information, so what that 8-bit microprocessor will do, that 8-bit microprocessor will first process 8-bit data, it takes some time, and then again it processes the rest 8-bit data. But for a 16-bit microprocessor, if the data is 16-bit, the microprocessor will process the total 16-bit data at a particular instant. That means for 8-bit microprocessor, if it wants to process 16-bit data, it should first process 8-bit, then again process 8-bit. So it takes longer time than a 16-bit processor. Similarly, a 32-bit processor will take less number of times to process a data or some information. So higher the word length, better the microprocessor is. So the word length of a microprocessor, if the word length is more, it is more advanced, and it takes less number of time for processing the same amount of data. A 32-bit microprocessor will take less time than that of a 16-bit microprocessor. A 16-bit microprocessor takes less time than that of a 8-bit microprocessor. Now, different available registers in microprocessor 8085. Another thing is that when we consider the word length of a microprocessor, as 8-bit microprocessor, its accumulator, general purpose registers, they are of 8 bits. So its internal structure is like this, so that it can process 8-bit data. Now what is registers? Registers actually a group of flip-flops. Now flip-flops we studied in digital electronics. A group of flip-flops is 8 bits. So an 8-bit word length microprocessor, its general purpose registers, its accumulator, they are of 8 bits each. That is why they can process 8-bit data at a particular time. So higher the bits, so the registers should be higher. A 16-bit, for a 16-bit processor, its register should be 16-bit. So like this. Different available registers in microprocessor 8085. Accumulator or register A. Accumulator is the most vital register in 8085 microprocessor. Accumulator can act as a register, general purpose register, BCDE, HL. These are general purpose registers which I will discuss later. Also, accumulator have a special function that accumulator can store the result of an arithmetic or logical operations. That is, suppose I want to add two numbers, two 8-bit numbers. So one number I should store it in accumulator, and the other number I should store it in any other register. And when we add these two numbers, the content of the accumulator will change and it will reflect the result. So the results of an arithmetic operation or logical operation means AND logic or logic. Arithmetic operation means addition, subtraction. So all the results of an operation stored in accumulator or register A. Next, general purpose registers in pairs. So B, C, D, E, H, L. There are 6 general purpose registers are there in 8085 microprocessor. Now, if I want to do a 16-bit operation, can I do it? Yes, I can do it. BC register, they can act as a pair. So there are 3 pairs of general purpose registers in 8085: BC, DE and HA. There should not be any pair BD, or there should not be any pair BL. So the pairs are fixed. So BC register, in BC register, B register is called high order register and C register is called low order register. So among these pairs, DE register, D register is the high order register, E register is the low order register. H register is the high order register, L register is the low order register. So B C D E H L, these pairs of registers, B D H, these three registers, B D H, these three registers, they are high order registers. C E L, these registers, they are low order registers. The above registers are of 8 bits, means individually B register is 8 bit, individually C register is 8 bit, D register is 8 bit, E register is 8 bit, H register is 8 bit, L register is 8 bit individually. But if we consider them as a pair, that is BC, BC register, if we consider BC register as a pair, it will become a 16-bit register. That is B register 8 bit, C register 8 bit. So these registers we require for some 16-bit operations. For some 16-bit operations, these pair of registers we use. Another, if anyone asks you that is there any 16-bit registers in 8085 microprocessor is? Yes, there are two 16-bit registers in 8085 microprocessors. One is SP, another is EC. SP stands for stack pointer and PC stands for program counter. Actually, why these registers are of 16 bits when all the other registers are of 8 bits? Actually, 8085 microprocessor, its address bus is 16 bits. That is, one register of 8085, it can store 8-bit data, but if I want to locate that register, if I want to address that register, this is a 16-bit. So SP and PC, these registers can store the address of a particular register. That is why they are 16-bit. That means, what is this? In a town, there may be many homes. If in a particular home there are different materials are there, so those materials are data. But if I want to address a particular home, so that is actually address of that home. Similarly, in 8085 microprocessor, one register can contain 8 bit of information data. But if I want to address that register, that means if I want to find that register, we should use a 16-bit address. So that 16-bit address stored in stack pointer and program counter register. So there are two registers in 8085 which are of 16-bit register. Now there are some definitions, these definitions which we use. First is T-state. What is T-state? Processors work in synchronization with a periodic signal called clock signal. Microprocessor, it is a digital clock driven device. That is, it has some internal clocks in it, which is totally connected with the frequency of that processor. The T is actually time period. Processors work in synchronization with periodic signals called clock signal. The part of any operation carried out during one time period of this clock signal is known as a T state. T is time period. Sometimes T state is also used to refer to a time of one clock period. For studying the rest of the concept, it becomes a basic unit of measuring time. So, if T is less, that means if the time period is less, frequency will be more. That means if a processor is fast, its T will be low. If its T will be low, its frequency will be high. So it is a very important parameter of any microprocessor or any computer. In 8085 microprocessor or in any microprocessor or in any computer, each instruction takes some time for its execution. Some instruction in 8085 can take 3T state, some may take 4T state, some may take 7T state. So like this, different T states are there. T states means if an instruction takes 4T state and if an instruction takes 3T state, so the instruction which take 3T state, it takes less time. So when when anyone write a program, you should remember two things. One is pace optimization, one is time optimization. If you write a program which consumes more space and it takes more times, then the same problem can be done with a different algorithm, different flowchart, which takes less amount of time and less space. The second programmer is good than the first programmer. So when anyone write a program, you should be optimized with respect to time and with respect to space. Next, instruction cycle. For the execution of any instructions, basically two steps are followed: fetch and then execute. Fetch means the instruction, which instruction should be executed, and fetch means the execution portion. The time or the number of T states required to fetch and execute an instruction is called an instruction cycle. That is, different instruction have different instruction cycle. Next, fetch cycle. When we write an assembly language program, every instruction of that program is converted to corresponding hex codes, which is then converted to binary and is stored somewhere in the memory. That is, hex code means hexadecimal number system is there. So the assembly language programming, it converts to hex code for its execution, and again it becomes binary codes. During the process of running an uploaded program, the processor first has to read from the memory the instruction that is to be executed. The process of reading the code for the instruction to be executed is called the fetch cycle. That is the instruction which we write. The processor first should read that instruction and then it will execute. So we can say that during this cycle, instruction to be executed is fetched from memory. That is, we write some instruction in that microprocessor, and the microprocessor first it will read that instruction. That means it will fetch that instruction. The microprocessor should know that which instruction it should execute. So that is actually is called fetching. It will fetch that instruction, and then it will then the time will come for its execution. So the process of reading the code for the instruction to be executed is called the fetch cycle. We can say that during this cycle, instruction to be executed is fetched from that memory. Next is execution cycle. That is, first the microprocessor will fetch that instruction and then it will execute the instruction to get the actual result or to achieve the goal. Execution cycle. After fetching the code for the execution that is supposed to be executed, the next step is to execute that instruction. This process is referred to as an execution cycle. So, different cycles are there: fetch cycle, execution cycle, instruction cycle. So, if the time is less, the programmer is good. Next is machine cycle. The time required for the microprocessor to access memory or an I/O device, either for a read operation or a write operation, is called a machine cycle. That is, memory means memory and I/O devices mean different external devices which we connect with that microprocessor. I/O devices means it is a keyboard, it may be a mouse, keyboard. Through keyboard, mouse, we give instruction. I/O device may be a webcam, it may be a printer, it may be a scanner. So the time required for the microprocessor to access memory or an I/O device, either for a read operation or write operation, is called a machine cycle. So different cycles we read. So one thing is that common is this is the time. So if the time requirement is more, then if you, for the same problem, if a programmer writes a program whose time requirement is more, and the second programmer writes a program whose time requirement is less, so we choose the second program or second option because of less amount of time required for the same purpose. So, last thank you for your patience.